sodium thiosulfate. Here sodium thiosulfate Na2H2O3 5H2 is also known as a hypo. It is the salt of sulfuric acid. Sodium thiosulfate is a salt of thiosulfuric acid. Thiosulfuric acid having the formula H2S2O3. In the similar way, Na2H2O3 means S double bond S, ONA, ONA and double bond O. Here in the thiosulfate, two sulfur atoms are there. One of the sulfur having -2 oxidation state, another sulfur having +6 oxidation states are exist. Two sulfur atoms are there, one of the sulfur having -2, and this is the central sulfur, this is the terminal sulfur. The central sulfur having +6 oxidation state, the terminal sulfur having -2. Therefore, average oxidation state is equal to +2. Average oxidation state in sodium thiosulfate is equal to +2. Here, the sodium thiosulfate is also known as efflorescent. Is also known as efflorescent substance. Efflorescent substance means the substance which can release water molecule is called efflorescent. Na2H2O3 5H2O. On heating, it loses water molecule. Therefore, this is known as efflorescent. Another term is also there, that is hygroscopic or deliquescent. Hygroscopic means the substance which can absorb water molecule from air is called hygroscopic. వాటర్ని అబ్జర్వ్ చేసుకుంటే హైగ్రోస్కోపిక్, వాటర్ రిలీజ్ చేస్తే ఎఫ్లోరెసెంట్. హైగ్రోస్కోపిక్ అన్నా డీలిక్విస్కెంట్ అన్నా బోత్ ఆర్ సేమ్. Hygroscopic or deliquescent means compound which can absorb water from air is called hygroscopic or deliquescent. Efflorescent means substance which can release water molecule is known as efflorescent substance. Now in the sodium thiosulfate, the average oxidation state of sulfur is equal to +2. Two sulfur atoms are there. One of the sulfur having -2 and another sulfur having +6 oxidation states are exist. Now the preparation methods of sodium thiosulfate. Here sodium thiosulfate can be prepared by when sodium sulfite Na2SO3. Here Na2SO3 is called sodium sulfite. Sodium sulfite on heating with colloidal sulfur. Here the colloidal sulfur is called plastic sulfur or Chi sulfur. Here the sulfur is exist as a different allotropic forms, alpha, beta and gamma form, and Chi sulfur is also exist. Alpha, beta and gamma form are containing S8 units. S8 units are exist as a Fokker ring configuration, and plastic sulfur or Chi sulfur containing S6 units. S6 unit having chain conformations are exist. The plastic sulfur is known as a colloidal sulfur. Here sodium sulfate and boiling with colloidal sulfur to form a compound Na2H2O3. Sodium thiosulfate is formed. Sodium thiosulfate. Sodium thiosulfate is formed. Na2H2O3. Na2H2O3 is called sodium thiosulfate. Second method used for preparation of sodium thiosulfate is the Springs method. The Springs method used for preparation of sodium thiosulfate. The Springs method used for preparation of sodium thiosulfate. In the Springs method, when the compound of sodium sulfite on heating with iodine, iodine means we have to take I2. We have to take the compound of Na2SO3, sodium sulfite. Na2SO3 is called sodium sulfite. Reaction with iodine with sodium sulfide, Na2S. Na2S is called sodium sulfide, IDE. Na2S is called sodium sulfide. Here this is the compound changes into Na2S2O3, sodium thiosulfate, and sodium iodide is also produced in the process. Sodium sulfide on heating with iodine with sodium sulfide, IDE. Na2S is called sulfide. Na2SO3 is called sodium sulfite, and this is called thiosulfate ion only. In the Springs method, the reagent used for preparation of hypo is Na2SO3, iodine, Na2S is used. For the preparation of Na2S2, for the preparation of Na2S2O3, the reagents are Na2SO3, I2 and Na2S. Na2S are used. These are the preparation methods of hypo and the properties of hypo solution. The properties of hypo solution. Properties of hypo. In the physical properties, here hypo solution is a efflorescent substance. Efflorescent means substance which can release water molecule. is known as a efflorescent substance. Now the first one is action of heat. Sodium thiosulfate, hydrated sodium thiosulfate. The hydrated sodium thios the hydrated sodium thiosulfate is known as a hypo solution. The hydrated sodium thiosulfate heating up to 215 degrees centigrade. It loses water molecule and it loses water molecule to form a compound Na2S2O3 and 5H2O. Up to 215 degrees centigrade, it loses water molecule. Here, if the sodium thiosulfate heating above 223 degrees centigrade, greater than 223, more than 223 degrees centigrade, the sodium thiosulfate decomposed into sodium sulfate, Na2SO4 and Na2S5, sodium polysulfide. Na2S5 is exist. Up to 215 closes only water molecule. After the casting of 215 degrees centigrade, sodium thiosulfate is participating in decomposition to form a compound of Na2SO4 and Na2S5 is exist. Here, this is the Na2SO3. Na2SO3 is called sodium sulfite. Na2SO3 is called sodium sulfite. Na2S is called sodium sulfide, IDE. This is the ITE. Na2SO4 is called sodium sulfate. It is the sodium sulfate, ATE. Sodium sulfate, Na2SO4 is called sodium sulfate only. The next one is action of acids. Action of acid. Here, the sodium thiosulfate, when treated with acid like HCl, Na2S2O3, Na2S2O3 5H2O, Na2S2O3 5H2O, sodium, when treated with acid like HCl, to produce a compound Na and Cl to form NaCl, sodium chloride. NaCl plus one of the compound SO2, SO2 plus S plus H2O is produced. S plus H2O is produced. When treated with acid like H2SO4, when treated with acid like H2SO4, Na2S2O3 plus H2SO4, Na2S2O3 react with HCl to form NaCl. Na2S2O3 react with H2SO4 to form a compound Na2SO4, sodium sulfate. Remaining compound is same, SO2 plus S plus H2O is produced. Here hypo solution when treated with acid like HCl to form a compound NaCl plus SO2 plus S. When hypo solution Na2S2O3 5H2O treated with acid like H2SO4 to form a compound Na2SO4 SO2 plus S. ఇక్కడ ఏముంది HCl అయితే to produce a compound NaCl. By using H2SO4 to form a compound Na2SO4, the common compounds are SO2 plus S plus H2O is produced. The next one is the oxidation reaction. The reducing property, the reduction reaction of hypo solution. The reduction reaction of hypo solution. Here hypo solution used as a anti-chloro substance. Anti-chloro means used for removal of excess of chlorine in textile industry is known as anti-chloro substance one. No doubt. Note చేయండి anti-chloro గురించి డిస్కస్ చేద్దాం. The reducing action of hypo solution. The reducing action of hypo solution. Here the hypo used as a anti-chloro substance. Anti-chloro means the substance used for removal of excess of chlorine. The substance used for removal of excess of chlorine is known as anti-chloro substance. Here hypo is used as a anti-chloro. Anti-chloro means substance used for removal of excess of chlorine is called anti-chloro substance. In the textile industry, Cl2 used as a bleaching agent. Here is some Cl2 particles present on the textile. The Cl2 damage the textile cloth. So we have to remove the excess of chlorine present in a cloth. The excess of chlorine can be removed when the cloth dipped in. After the bleaching, the cloth dipped in hypo solution. This hypo removes the excess of chlorine present in a cloth. Therefore, the type of phenomenon is called anti-chloro process. The reagent used for removal of excess of chlorine is called hypo solution. Hypo solution one. It is in this process when hypo Na2S2O3 react with chlorine water. When hypo solution react with chlorine water, then the formed compounds are one of the properties Na2SO4, Na2SO4 plus 2HCl and sulfur can be precipitated. In the Na2S2O3, oxidation state of sulfur is equal to 2.0. This is the plus 6 and this one is taken as a 0. Plus 2 to plus 6 increases, plus 2 to 0 decreases. Here Cl2, 0 to minus 1 decreases under reduction. Therefore, Cl2 is act as an oxidizing agent and hypo solution is act as a reducing agent. Plus 2 to plus 6 increases. Increases means it is undergoes oxidation. Therefore, this one is act as a reducing agent. This one is act as a reducing agent. Next, iodometric reaction. Iodometric process. The iodometric process used for estimation of hypo solution. Quantitatively, hypo can be identified by using iodometric process. In the iodometric process, the standard solution, I2, iodine solution used as a standard solution. The standard solution means the concentration known solution is known as a standard solution only. Here in this case, when hypo, that is Na2S2O3, react with iodine to form a compound Na2S4O6 and NaI is produced. Na2S4O6 is called sodium tetrathionate. It is the salt of tetrathionic acid. Na2S4O6 is a sodium tetrathionate. It is the salt of tetrathionic acid. In the tetrathionic acid, number of SS bonds are always equal to n minus 1. N indicates the number of sulfur atoms. Total number of sulfur atoms are 4. 4 minus 1 and it is having 3 sulfur atoms. 3 SS bonds are exist. In the Na2S4O6, the terminal sulfurs having plus 5 oxidation state. The central sulfur having 0 oxidation states are exist. Here Na2S2O3 is called hyperreact with iodine to form Na2S4O6 plus NaI. In this process, number of equivalents of iodine is equal to number of equivalents of hypo solution Na2S2O3. In this process, one equivalent of iodine is always react with one equivalent of hypo solution. One equivalent of iodine is always react with one equivalent of hypo solution. Here number of equivalents means the normality of iodine into volume of iodine. Normality is equal to number of equivalents by volume. So number of equivalents is equal to normality into volume. Here normality of hypo solution into volume of hypo solution. Here in this process, the equivalent weight of iodine, iodine is equal to, here in this process I2 changes into 2I minus, I2 changes into 2I minus 0 to minus 1. So n factor is minus to 0, that is equal to 2. N factor of iodine is equal to 2. So equivalent weight of iodine is equal to molecular weight by 2. Molecular weight of iodine is 254, 254 by 2, that is equal to 127. So in this process, number of equivalent of iodine is always react with the number of equivalents of hypo. Number of equivalents are obtained by normality into volume of iodine is equal to normality into volume of hypo solution. In this process, if the normality of iodine is known, based on that one, normality of hypo can be calculated. If the normality of hypo is known, based on that one, we have to calculate normality of iodine. This is called iodometric process. So in this process, when hypo react with iodine to form NaDH4O6, NaDH4O6 is called sodium tetrathionate. Thionic, it is the salt of thionic acid. This one is called sodium tetrathionate only. Next, here hypo react with reaction with AgNO3. Reaction with AgNO3, silver nitrate. When hypo react with silver nitrate to form a white precipitate is produced. And when Na2S2O3 react with silver nitrate to form a compound Ag2S2O3. Ag2S2O3 plus NaNO3. It is exist as a white precipitate. Here the name of this compound is silver thionate. Silver thionate is formed. Ag2S2O3 is exist as a white precipitate. The name of that compound is silver thionate. Here the silver thionate on long standing Ag2S2O3 on long standing decomposed into Ag2S in the presence of water, Ag2S silver sulfide. Here the silver sulfide is exist as a black color precipitate. When AgNO3 and when hypo solution is added to AgNO3 solution, first to form a white precipitate. White precipitate is called silver thionate. The white precipitate slowly changes into black color. The formation of black color indicate it changes into Ag2S silver sulfide is exist. When hypo solution is treated with AgNO3, first to form a white precipitate having the formula Ag2S2O3, Ag2S2O3, that is exist as a white precipitate. The white precipitate on a long standing, the white color changes into black color. The formation of black color indicate that is the formation of Ag2S, that is a silver sulfide one. Next, reaction with AgBr, silver bromide. Here in this process, the hypo used in photo fixing agent. In the photographic industry, the photo fixing agent, hypo solution. Hypo solution is as a photo fixing agent. So in this process, in the olden days, nowadays we have to use a memory card for photographic. In the olden days, photographic films are used. The photographic film containing silver bromide AgBr coating. If the photo is taken, the shadow is fixed on the photographic film in the place of silver bromide. Here, remaining silver bromide is present on the photographic film can be removed by addition of when dissolved in hypo solution. So photographic development can be done. The photographic film dipped in hypo solution, the hypo reacted with excess of silver bromide present on the photographic film. Shadow part photographic film ki stick అయిపోయి ఉంటుంది. నాన్ షాడో పార్ట్ అనేది మనం రిమూవ్ చేస్తాం. రిమూవ్ చేయడానికి వాటర్ లో డిజాల్వ్ కాదు. సిల్వర్ బ్రోమైడ్ ఈజ్ నాట్ సాల్యుబుల్ ఇన్ వాటర్. సో బై అడిషన్ ఆఫ్ వాటర్ the excess of silver bromide cannot be removed. The silver bromide is easily soluble in hypo solution. The excess of silver bromide present in photographic film can be removed when the photographic film is dipped in hypo solution. So photographic development can be done by using a hypo solution only. Here, when silver bromide AgBr react with sodium thiosulfate Na2S2O3 to form a soluble complex of Na3AgStO3 taken twice is exist. Here, so this is the soluble complex of sodium argento. This one is called sodium argento thiosulfate. Sodium argento thiosulfate is exist. Na3AgStO3 taken twice is called sodium argento thiosulfate. It is exist as a soluble complex. This one is exist as a soluble complex. Here, the soluble complex can be removed by addition of excess of water volume. That one is known as a photographic development and photographic fixing. Can be done by using a hypo solution. In this process, the formed compound is taken as sodium argentothiosulfate. The formula of sodium argentothiosulfate is Na3AgStO3 taken twice. Sodium argentothiosulfate. Next, the reaction with copper sulfate solution. Reaction with copper sulfate CeSO4. When hypo solution Na2S2O3 react with copper sulfate CuSO4 to form a soluble complex of Na4 Cu6 S2O3 5 times. It is a complex compound. Na4 C6 S2O3 taken 5 times are produced. Name of this compound sodium cuprothiosulfate. Sodium cuprothiosulfate. Name of this complex is taken as a sodium cuprothiosulfate is exist. These are the important properties of hypo solution. Here hypo used as a anti-chloro substance. Anti-chloro means the substance used for removal of excess of chlorine. Removal of excess of chlorine is known as a anti-chloro substance. In the textile industry, the cloth can be bleached by using a chlorine water. Here the chlorine water can be act as a bleaching agent. Here the cloth dipped in chlorine water, some chlorine particles are present on that cloth. If the chlorine particles are present on the cloth, the chlorine damages the cloth. Now in that case, we have to remove the chlorine present on a cloth. So the chlorine present on a cloth can be removed by using hypo solution. The removal of chlorine on a cloth is called anti-chloro process. The reagent used for removal of excess of chlorine is called anti-chloro. The anti-chloro reagent is which one? Hypo solution is act as a anti-chloro substance. In the anti-chloro process, Cl2 plus H2O, HCl and sulfur can be precipitated. Iodometric process. Iodometric means iodine used as a standard solution. That is used for estimation of hypo. Hypo. By using hypo, we have to estimate the iodine. By using iodine, hypo can be estimated. In the presence of potassium NO4 is also estimated by using this process also. In hypo react with iodine to form sodium tetrathionate. It is a salt of tetrathionic acid. To form a compound sodium tetrathionate and sodium iodide is exist. In this process, the number of equivalents of iodine is equal to number of equivalents of hypo solution. Number of equivalents can be calculated based on normality into volume. Normality of I2 into volume of I2 is equal to normality of I4 into volume of I4. In this case, equivalent weight of iodine is taken as a molecular weight by 2. The reaction with AgNO3. Hypo solution react with silver nitrate to form a white precipitate of silver thionate. The white precipitate on long standing changes to black color. The formation of black color indicates the formation of AgTS, that is silver sulfide volume. Reaction with AgBr, that is the point indicates the hypo solution is as a photo fixing agent in the photographic industry. Here hypo react with silver bromide to form a compound of sodium argentothiosulfate. This one is exist as a soluble complex. The formula of sodium argentothiosulfate is Na3AgStO3 taken twice. And also reaction with cupric sulfate, copper sulfate to form a complex of Na4 Cu6 S2O3 5 times are exist. It also exists as a soluble complexes. These are the properties of hypo solution. The important uses of hypo. Hypo is also used as a anti-chloro substance, removal of excess of chlorine. Hypo is also used in iodometric process, estimation of iodine. And hypo is also used in photo fixing agent. Is also used in photo fixing agent. And hypo solution is also used as a antiseptic in property. Hypo is also used as a antiseptic in property. అంటే జనరల్ గా స్కిన్ మీద ఎలర్జీ అనేది డెవలప్ అయ్యిందంటే స్కిన్ అలర్జీస్, ఆ స్కిన్ అలర్జీస్ ని డిక్రీజ్ చేయడానికి ఏం చేస్తారంటే హైపో లెమన్ జ్యూస్ రెండు మిక్స్ చేసి ఆ ఎలర్జీ మీద అప్లై చేస్తాం అనుకోండి, ఆ ఎలర్జీ అనేది మనకి ఓవర్కమ్ చేస్తాం. సో హైపో సొల్యూషన్ ఇస్ ఆల్సో యూజ్డ్ యాజ్ ఏ యాంటీసెప్టిక్ ప్రాపర్టీ. ఓకే, నో డౌట్. పెట్టుకుంటావు ఇది చెప్పు. డైరెక్ట్ కనపడుతుంది రాముకి. అక్కడ రాము మ్యూట్ చేయాలి. రాము మ్యూట్ చేస్తే నీకు వినపడుతుంది. ఉంటుందా? వినపడుతుందా? ఓకే, చెప్పేస్తా డైరెక్ట్గా. నాకు వినిపించట్లేదు. ఇది లెంత్ ఎక్కువ. ముందు రాముతో చెప్పు. నాగూర్ సార్ మాట్లాడతారు మెటీరియల్ గురించి అని ఒక మాట. రాముతో ఒకసారి ఫోన్ చేసి చెప్తే. ఓ పని చేయి, నువ్వు ఆ నెంబర్ ఎంటర్ చేసేస్తే నువ్వు వెళ్ళిపోవచ్చు మీటింగ్లోకి డైరెక్ట్గా. ఉందా? ఐడియా ఉందా? నెంబర్ చెప్పనా? ఎంటర్ చేసేసి వెళ్ళిపో. నెక్స్ట్ బ్రేక్.
సార్ శ్రీనివాస్ సార్, న్యూ చాప్టరా? గ్రూప్ 17th ఎలిమెంట్స్ కదండి?
17th గ్రూప్ ఎలిమెంట్స్.
అంటే 16th కంప్లీట్ అయిన తర్వాత 17th ఈరోజు స్టార్ట్ చేశారు.
స్టార్ట్ చేశాను. ఓకే. Next is the oxidation state of 17th group element. Oxidation states of 17th group elements. Oxidation states of 17th group elements. The general electronic configuration of 17th group elements are NS2, NP5, ND0 except fluorine. Here fluorine oxidation state is always taken as a -1. Fluorine oxidation state is -1 due to the fluorine having high electronegativity. In the Warhol periodic table, the fluorine is exist as a fixed oxidation state, that is -1. The fluorine do not shown by variable oxidation state due to the absence of D subshell. Due to absence of D subshell, the fluorine do not exhibit variable oxidation state. The fluorine is always exist as -1 due to high electronegativity of fluorine. Remaining elements we have to take different oxidation states are possible. -1 plus 1, -1 plus 1 plus 3 plus 5 and plus 7 oxidation states are also possible. The remaining elements exist as a -1 plus 1 plus 3 plus 5 plus 7 can be possible. Here in the plus 1 or -1 means valence shell contain 1 unpaired electron. 3 means valence shell containing 3 unpaired electrons. 5 oxidation state means in the valence shell containing 5 unpaired electrons. 7 means valence shell containing 7 unpaired electrons are exist. Now the general electronic configuration of 17th group element except fluorine we have to take NS2, NP5, ND0 configuration. In the nth level, vacant d orbital is exist. Here NS2, NP5, S subshell containing 2 electrons and P subshell containing 5 electrons are there. 1, 2, 3, 4, 5 and d orbital is vacant d orbital. This is the ground state electronic configuration. In the ground state electronic configuration, valence shell containing only 1 electron. Therefore, oxidation state is taken as a -1 or +1 is possible. -1 or +1, one of the can be possible. Valence shell contain only 1 unpaired electron. In the first excited state, means electron present in P subshell. Move towards D level. Therefore, electronic configuration in the first excited state is NS2, NP4 and ND1. NS2, NP4 and ND1. Here S subshell containing 2 electrons and P subshell containing 4 electrons. 1, 2, 3, 4 and D subshell containing only 1 electron. The D subshell contains only 1 electron. In the first excited state, number of unpaired electrons are 3. 3 unpaired electron means +3 oxidation state is possible. +3 and -3 is also possible. +3 oxidation state is exist. In this case, intermixing of 1s and 3p orbitals. 1s and 3p and 1d. Two types of hybridations are possible. sp3 or sp3d is also possible. In the first excited state, the central atom of halogen undergoes 2 types of hybridization. sp3 is also possible and sp3d is also possible. In the sp3 hybridization, intermixing of 1s and 3 p orbital is called sp3. In the sp3 level, two lone pairs are there, the two lone pairs. So in this case, the shape of the molecule is taken as a angular geometry. Shape of the molecule is taken as a angular geometry. In the first adjusted sp3d, it is having two lone pairs and three unpaired electrons are participating in bonding. Therefore, three bond pair of electrons, two lone pair and three bond pair. sp3d and two lone pair and three bond pair. Then the shape of the molecule is taken as a T-shaped structure. Then the shape of the molecule is taken as a T-shaped structure only. In the second excited state electronic configuration, in the second excited state, the electron pair present in the p sublevel transport into D. So in that case, electronic configuration ns2, np3 and nd2. ns2, np3 and nd2. Here s subshell containing 2 electrons and p subshell containing 3 electrons and d subshell containing only 2 electrons are there. The d subshell contains 2 electrons. Here second excited state ns2, np3, nd2. Number of unpaired electrons 1, 2, 3, 4, 5. 5 unpaired electron means it is exist as a +5 oxidation state. In a given compound, the central atom if undergoes +5 oxidation state, that means 5 unpaired electrons are present in the valence shell. In that case, the central atom of halogen undergoes second excited state electronic configuration. In the second excited state, 1s, 3p and 2d. In these two types of hybridations are possible. One is the sp3 or sp3d2. sp3 or sp3d2. Here sp3 is possible. It contains one lone pair of electron. In the sp3 hybridization, two d orbitals are participate in pi bonding. One lone pair and sp3. The shape of the molecule is taken as a pyramidal geometry. Due to the sp3 and one lone pair, the geometry of the molecule is taken as a pyramidal geometry. In the sp3d2, one lone pair and remaining 5 unpaired electrons are participate in bonding. 5 bond pair. One lone pair and 5 bond pair. The shape of the molecule is taken as a square pyramidal geometry. Square pyramidal geometry. In the square pyramidal, the lone pair is present at equatorial position. The lone pair is present at equatorial position rather than the axial position. Now, the next is the third excited state electronic configuration. In the third excited state means electron pair present in S subshell transport into D sublevel. The electron pair present in S subshell transport into D sublevel. That is the third excited state electronic configuration NS1, NP3 and ND3. NS1, NP3 and ND3. Here in the NS1 configuration, S containing 1 electron and P containing 3 electrons, 1, 2, 3, and D containing 1, 2, 3, 4, 5. 3 unpaired electrons are there. In these two types of hybridizations are possible. One is intermixing of 1s and 3 p orbital. 1s and 3 p orbital, that is called sp3, or 1s and 3p and 3d. Therefore, the type of hybridization is called sp3d3. One is the sp3 hybridization, or in some cases sp3d3 also possible. sp3 means without lone pairs. The shape of the molecule is taken as a tetrahedral geometry. In the sp3 hybridization, the shape of the molecule is taken as a tetrahedral. sp3d3 shape of the molecule is taken as a pentagonal bipyramidal geometry. Pentagonal bipyramidal geometry is exist. In the pentagonal bipyramidal, and for example, you have to take AX7. Example of IF7, AX7 or IF7. These are the interhalogen compound. AX7 and IF7 are interhalogen compound. In the IF7, pentagonal bipyramidal, 5 fluorine atoms are present in same plane. 5 fluorine atoms are present in same plane. This is the equatorial position. Remaining 2 fluorine atoms are present in axial position. This is the axial. These are known as equatorial position. That is called pentagonal bipyramidal geometry. Here in the square pyramidal geometry, one lone pair is present at equatorial. Remaining 5 bonds are present at 3 are present at equatorial, 2 are present at axial position. Therefore, the type of geometry is known as the square pyramidal geometry only. These are the different type of oxidation state of these elements. And in the overall periodic table, the fluorine is always exhibit only one type of oxidation state. That fluorine is always exists as a negative oxidation state, that is -1. Due to fluorine is exist as a -1 oxidation state means the fluorine having high electronegativity exist. Other elements we have to take. The other elements are participate in different type of oxidation state. -1, +1, +3, +5, +7 is also possible. In the minus R, 1 means valence shell contain 1 unpaired electron. 3 means valence shell contain 3 unpaired electrons. 5 means valence shell containing 5 unpaired electrons. 7 means valence shell containing 7 unpaired electrons are there. In the general electronic configuration, NST, NP5, ND0. In the ground state, only 1 unpaired electron is there. In that case, the central atom undergoes +1 or -1 oxidation state only. The some element is given. The oxidation state of the central atom is taken as a +1. In that case, we have to take ground state electronic configuration only. In the first exit state, electron present in p sublevel transferred into D. That electronic configuration is NST, NP4, ND1. In these, 3 unpaired electrons are there. Therefore, oxidation state is taken as a +3. In these, 2 types of hybridations are possible. sp3 and sp3d. sp3, 2 lone pair. Geometry of the molecule is angular. sp3d, 2 lone pairs and 3 bond pairs. Shape of the molecule is taken as a T-shaped structure. Example is taken as a AX3 type compound, that is ClF3. AX3 or ClF3. Here the T-shaped geometry means Cl, fluorine, and this is the fluorine and fluorine. It contains 2 lone pair of electrons. And these 2 lone pairs are present at equatorial position. And second exit state, electron present in p sublevel transferred into D. 5 unpaired electron and oxidation state is taken as a +5. In the interhalogen compound, the halogen which one having +5 oxidation state, we have to take second exhausted electronic configuration. In the second exhaust state, 2 types of vibrations are possible. sp3 and sp3d2 is also possible. sp3, 1 lone pair. Shape of the molecule is pyramidal. 1 lone pair. sp3d2, 1 lone pair and 5 bond pair. Shape of the molecule is taken as square pyramidal. In the third exhaust state, the electron present in S subshell is transferred into D. The electron present in S subshell is transferred into D. So in the third exhausted electronic configuration, we have to consider NS1, NP3 and ND3. Now in these intermixing, 2 types of hybridations are possible, sp3 and sp3d3. Only sp3. Remaining, if the central atom undergoes sp3, the D electrons are participate in 5 bond formation. In the sp3 without lone pair, geometry of the molecule is taken as a tetrahedral. sp3d3, the shape of the molecule is taken as a pentagonal bipyramidal geometry. Example of AX7 and IF7. In the pentagonal bipyramidal, 5 bond pairs and 1 central atom are present in 5 bond pair and central atom are present in equatorial position. Remaining bond pair, one is present in upward, second one is present in downward. These positions are known as axial position one. These positions are known as axial position. These are the oxidation states of 17th group elements. Okay, note చేయండి అమ్మది. మాట్లాడతావా వాళ్ళు మాట్లాడారు, సరే సరే అలాగే ఓకే. నోట్ చేయండి ఆక్సిజన్ స్టేట్ ఆఫ్ 17th group elements.